Hello everyone and welcome to Excited Nuclei channel. So today we are going to create our next project and that is optics calculator. Now moving on to the project part, let me share my presentation to show you the introduction about that. So this is going to be our project 6 which is optics calculator. This calculator is going to be a console based program basically for students and enthusiasts for various optics related quantities like object distance, image distance, magnification, refractive index, and other things. We are basically going to create a function app that is going to calculate all these features. Now, the features that is going to this app is going to have is actually using the lens formula. We are going to calculate focal length, object distance, and image distance. Oh, sorry, I have put the same thing twice actually, so please ignore. Then the magnification and the last is refractive index, basically using Snell's law. So to give you summary, Snell's law is basically a formula that is used to calculate the refractive index of any material by calculating the angle of incidence and angle of refraction and taking the ratios of them, basically sine inverse. So and the last, the program is going to have an exit option. And the concept used for this app is going to be functions, loops, conditional statement, basic arithmetic operations, and input output. So that's all about the project introduction. Now let's move on to the coding part. So as you can see, I have created the basic structure for this program to basically save the time. So for this program, we are going to use this cmath library, and we are going to create these few functions that is going to help us in the things. So moving on to this first function. So this is just it is nothing but just a utility function that helps us to print something onto the console and ask user for the output for the specific task. So how this function is going to work is quite simple. It is going to just take a prompt. So prompt, before taking the prompt, it is going to, we should first define a variable int, and int is going to be like choice. Now this choice is going to be the input from the user. Now before input, we have to print something onto the console, and that something is going to be our prompt here. And then we are going to take input from the user. Now that input is going to be like choice. Now at last we are going to return the same choice that user have made, basically to tell the function that okay, user want to do this, you should proceed with that. Now we have created this function. Let's test it. For now, let's just call this function and see whether this is working or not. Now if I put get positive input, and for the prompt part, let's say test input function. Now this is the prompt that I have given to it. Now when I try to run this, sorry, so as you can see, it is asking for our input. Let's say one. Let me clear that to show you clearly what is happening. Now let's just save the input into something. So let's say I, and at last we are going to see out I. So let's just run this to show you what this code is going to do. So text input, let's say one. So it returned once. So the functionality of this function is working. Now moving on to the next part, we are going to see about the lens formula. So as you can see the lens formula here, lens formula is nothing but just this whole formula which allows us to calculate the focal length if we know image distance v and object distance u. So this is the formula that can be used for calculating various things, like if we know focal length and object distance, we can calculate the image distance actually. So this is what this function is going to do. Now to make that, we have to create a menu asking user that what it wants to calculate. So to ease and save the time, let me just copy and paste that menu here. So as you can see, I have created the lens choice. So lens choice is nothing but the choice that user is going to make. That means, okay, I want to use, let's say, focal length. So in this case, I'm going to ask user that, okay, if you want to calculate focal length, please enter the choice one for that function to use that functionality. So this is what it is going to return us. Now, as we are working with lens formula, we must also have something like u, v, and f, which are object distance, image distance, and focal length, respectively. Now, at last, we are going to use the switch statement, and in the switch statement, we are going to call this lens choice. Basically, this is what it is going to check on. Now, we are going to use different cases. Now, let's say if the case is 1, that means we want to calculate the focal length here. So, this case is actually going to call us with something like first, user must know u, v, f. Now, why I have said that user must know? Basically, we are going to take the input from the user, and based on that, we are going to use this positive input, and we are going to write our prompt here, and the prompt is going to be really lengthy. So to make that really fast, okay, so as you can see, I have created a prompt, put semicolon, and again get. I'm going to explain that. So for now, so this is going to be v, and rather than object, this is going to be image distance. Put the semicolons and move on to the next part. Now, if we want to calculate the, you can see from the menu bar, if our choice is 1, then we want to calculate the focal length. Now, to calculate the focal length, we must know about the object distance and the image distance. Now, let me just write the formula for calculating this focal length here. So 1 divided by this 1 divided by v minus 1 divided by u. So this is what helps us. This is what is going to help us in calculating the focal length of any lens. Now, at last, I must return this f, so that our for our this case are actually going to complete. Or maybe rather than returning this statement, we can simply call C out here, and I believe that is what we can do. Sorry. So as you can see, the focal length here becomes centimeter per this thing. As you can see, now our focal length is created. We are going to put a break statement here. Why break? Because if we don't put the break statement here, it is going to execute the further cases that I am going to write here. Now, in the similar manner, we are going to write everything. So let me just copy and paste that. But this time, In the case 2, we have to calculate the object distance c, that means u. So if you want to calculate the object distance, we must know about this f and v. Now to calculate this f and v, we are just going to take input from the user. Sorry, yeah, and now so I think it moves to the other at the end of the, you can say, why that. Okay, so now let's do one thing. We are going to calculate the u here. Let me correct the this line first. So here first we are going to ask for the focal length, and for the focal length we are going to do one thing. We are going to, let's say, put focal length here. Now to, let's say, sorry, but let's keep the formatting same everywhere. Now focal length in centimeter. Now we have written the focal length, and there is also one thing that we must know, that if the focal length, let's say, if the focal length is in negative, or maybe there might be some cases where there is going to be negative focal length, so we should not ignore that too. So as you can see, we have written the focal length here, and now the only case that we are left with is just calculating this u value. Now to calculate this u value, what we are going to do, we are just going to simply copy and paste that. Now as you can see in the formula, this, if you want to calculate this 1 by f, we have to take this 1 by u on the left hand side and 1 by f on the right hand side, and after that do the same. That means we just have to replace u to f. That means if I put f here, and that formula is going to be created for uh, something like calculating the object distance. Now if we are going to put the object distance here, um, we can just simply calculate the sorry, we have to update that to calculate the u part, object distance. Now that u is actually calculated, also going to update that. Now in the similar way, we just have to calculate the case 3, which is going to be calculation of image distance. Now this is going to be u, and for the u we are just going to use this, because to calculate we must know this statement. And here we just have to do one thing. We have to reverse this 1 by f, 1 by u, and this is going to be this is going to be v, and also we are just going to put here v, and rather than object we are going to update this with image distance. Now as we have calculated this whole thing, everything should work just fine, because as you can see we have to calculate image distance, and image distance can be calculated in the way that if we take u, 1 by u on the other side, that means on the left hand side, we just have to add here and then do the same calculation for the whole thing. So this will calculate us This will let us calculate V. Now to test this lens formula, we are just going to put a lens formula here and call that. Now when I run this lens formula, okay, as you can see, our menu is printing and it is asking for us what we want to do. Let's say for now I want to calculate this image distance. So enter the object distance. So let's say if object is present at 4 centimeter and the focal length is 8 centimeter, that means f by 2 position. Then as you can see, the image is going to be at 2.67 centimeters, and this is going to be to the right. Now basically this is what this app is doing. It is going to calculate everything and return us with something. Now to verify that, we can just simply do some simple math that whether this is working or not, and I am damn sure this is working. Let me just quickly calculate it using my calculator app to see whether this is right or not. Now if I put a object and then this and this, so correct image distance should be for V, calculation of V. Oh, sorry, the change in this formula actually crashes this. Oh, sorry, we have to put negative sign maybe here. Now, if I try to run this again, and the last time we have written 4 and 8, enter your choice, let's say 3, 4, 8. Okay, now it's calculating everything good. That's all for this program. That means the lens formula thing. Now the next part that we have to calculate is this magnification, which is quite simple. Okay, let me just say that. Now for the magnification, that is quite simple thing that we can calculate. Also there is some problem, I believe there is. Oh yeah, I got it. We forgot the break statements. And also for case default, let's set it to the calculation of this focal length, so that even if our code is getting let's say some breakage or something, it is just run fine, everything and else. So our code is completed. Now for the magnification part, magnification is actually quite simple. We just have to divide the height of image and you can say height of object, and also we can also do one thing, and that is we can just put the image distance and object distance to get that thing, which is basically nothing but just linear magnification in our case. So let's do that. Now first we have to just print something like magnification as a heading. Why I'm doing so, I will tell you once I return this main loop. For now, just keep it to the mind. Now let's just call this double u comma v comma f. Maybe we don't need f here because we are not using the lens formula. We want m, which represent the magnification. Now if we want u is equal to v is equal to, now this time also we are going to use this u and v to basically use that. I'm just going to paste it from here. So as you can see, I have written this object and you can say image distance. The same thing as above. Now, what we need is just to calculate m. So m can be calculated by just doing a simple calculation, that is v by u. Now this will return us something like magnification, and at last we just have to output the line that the linear magnification m is equal to, and then the value of magnification. So this function is also working just fine. Now for the last part, which is the refractive index, we just have to first print the heading. Uh, Basically, I am copy pasting because to save the time. And next thing is we just have to create two variable, that is angle of incidence and angle of refraction. Sorry. So I is the angle of incidence and R is the angle of refraction here. We just writing it all because it's a good practice. Basically, think of name everything correctly. Now the next thing, we have to ask user for input. Now that can be done by simply calling this again get positive, and if I put get positive here, again here we can just angle of incidence sorry, my throat is actually not feeling well. So for the prompt part, we are going to actually ask for user to enter the input for, let's say, angle of incidence in degrees, because that's the main part, and angle of refraction in degrees. Now if I put that also here, sorry, copied the same damn thing. And yeah, angle of refraction. Now for the you can say calculation of refractive index. Refractive index, before calculating the refractive index, we have to convert this angle of incidence to angle of sorry, radians. Rather than degrees, we have to convert them into radians, and radians can be done by, you can say, 1 degree is equal to n by, basically n is a degree here, and n by, sorry, n multiply pi divided by 180. So this is how calculated n degrees can be converted into n radians, or the vice versa. Basically, this is n radians to be now n radians can be written like this. Now we just have to create a formula. Now to now the formula are in such a way that this m pi is nothing but just the pi value of the meth, and divided by 180 degree, and then multiplied to the angle of incidence. Basically, angle of incidence multiplied by pi divided by 180 degree, and that gives us the radians of angle of incidence. Now for the last part, we just have to do something like sine of radian value. That means double refractive index, maybe not, we don't need. Basically the scientific notation for refractive index is n. So what we can do is sine of radian of angle of incidence divided by sine of angle of radian angle of refraction. Now this expression result in the calculation of refractive index. Now at last we just have to, you can say, print this to console, and we are done with our, you can say, functions. We have completed lens formula, magnification and refractive index. Now we have to write our main loop. The main loop is written in some, you can say, in simpler format. That means first of all we have to create a variable int choice, basically int choice. Now we just have to create a, you can say, do while loop. So this do and while the condition is true. Now for now let's just choice not equal to, for now we are going to set for to the something like to stop the execution, and we are going to return 0. So this is how this function is going to work. Now let's complete this do loop. So in the do loop, basically do while loop, first we have to create a menu system. Now to create a menu system, we just have to create something like similar to this lens formula one. So I'm just going to copy and paste that. So as you can see, the optics calculator is what heading shows us. Then it is giving us the options that which features that you want to use. And at last it is showing that to exit the loop, you just have to type the for. And when user enter the for here, this condition become false, and this loop is going to exit. And that's all for the apps. And now let's complete this, you can say, loop statement. So in this situation, we are going to use switch statement. So switch, and here choice. Now in the choice, in the switch statement, there is going to be like 1, 2, 3, and 4 choices basically, and default one. So let's just create them. So case 1, or maybe I get an idea here. So rather than printing this whole thing, we can just put here something like invalid choice retry. So this same things can be used in the case statement here. For now, let's just ignore that and just write the lens formula. Call that lens formula here. Now for the case 2, we are going to call here magnification. Now for the case 3, we are going to do for the refractive index. Now for the case 4, we are going to put something like thank you or something, maybe exiting the program and goodbye. Yeah, that statement is going to be good. So for now, this statement, let me just copy and paste. Now for the default part, we are just going to paste the same thing as lens formula, which is invalid choice. Please retry, and this should do the thing for us. So So as we have created this whole program, now we just have to create all the, oh sorry, we have forgot to write the break statement everywhere. So, so now we have written this whole loop correctly, and we also have written this break statement. Maybe in the default statement we need not to put that. Let me just remove that. And default statement and the while and this return 0. I believe our main functionality is quite completed. So let's test this whole function. And to test this function, we have to run this. Now, when I run this program, okay, everything is working fine. That means it is asking for us. So first, let's test this exit statement, whether it is working or not. So exit is working good. Now for the lens formula, okay, lens formula executed and it shows the same options. Let's say focal length and so what we have used last time, we have used for 8 and that's give us 4 and 8. So this time we have used actually focal length. Let's see, we get the focal length. Okay, good. And now it's asking us for again the optics formula, optics calculator. Now let's say this time I'm going to use magnification. The magnification is working. It is asking for entering the object distance. Yeah, enter the object distance. So object distance, let's say 3 or maybe -3. We should include the case. And image distance should be like let's say 9. So the linear magnification is -3. Basically, image is shorter, and that's good. Now for the, you can say, calculation of refractive index, I'm going to see some values that we might need to use. Okay, let me search what should be the use case for Snell's law. Uh, mm, the use case, sorry, rather than use case, I should ask. You can say this. This should do. Maybe we should. So if I put n1 to 1 and n2 to 1.5, it should return 30. So if I put 1 and 1.5, it triggered the infinite loop. I don't know why. So we got an error. Third point right. Third point here. Refractive index. So refractive index. First of all, let me save that. So what's the problem here? Uh, so maybe this time. So maybe the values we have written is actually quite not up to the mark. So I get that. Maybe we need to use some other values. Some other values maybe like T and 15 degree. That just execute that again. And this time I am going to use this refractive index and 30 and P. So it gives us the refractive index. That's good. Right now our function is working good. Now execute it. So that's all about our, you can say, optics calculator. With this, we have wrapped up our sixth project, which is optics calculator. I hope you understand this video. And if you have any suggestion, please tell me in the comments. And also, I don't. I think that triggered thing that means the previous thing that we have triggered is actually due to the writing the wrong inputs for calculation of refractive index. That means 1 degree and 1.5 degree. We should work on that. Thank you. Thank you all.